Nancy aims to introduce a secure and intelligent architecture for beyond the 5th generation, also known as B5G, wireless networks. Leveraging artificial intelligence and blockchain, Nancy enables secure and intelligent resource management, flexible networking, and orchestration. In this direction, novel architectures, namely point-to-point connectivity for device-to-device connectivity, mesh networking, and relay-based communications, as well as protocols for medium access, mobility management, and resource allocation will be designed to optimize the mid-haul and front-haul. Nancy is expected to enable truly distributed intelligence and transform the network to a low-power computer. Likewise, by following a holistic optimization approach and leveraging the developments in blockchain, Nancy aims at supporting end-to-end personalized, multi-tenant and perpetual protection. Netcompany-Intrasoft was selected as the project integrator due to our exceptional track record in participating in and leading EU projects. Netcompany-Intrasoft is a leading European IT solutions and services group with strong international presence and expertise, offering innovative and added-value solutions of the highest quality to a wide range of international and national public and private organizations. The Research and Innovation Development Department works in close collaboration with other Netcompany-Intrasoft teams to bring technological and business innovation within the group, as part of the overall Netcompany-Intrasoft strategy on innovation. As the project's integrator, we meticulously oversee all testing and integration activities of the project. The main objective of the integration process is to unify all the Nancy technical components into a fully functioning platform. This work is performed in 2 releases. In order to reach this objective, every bilateral integration point between the Nancy components needs to be identified. From that point onwards, the consortium can start defining functional and integration tests, ranging from small scale to end-to-end. During the integration process, feedback is offered back to the developers for issue resolution and further refinement. In order to facilitate and streamline this process, Netcompany-Intrasoft provides a continuous integration, continuous delivery system. Netcompany-Intrasoft brings industry-standard best practices and automation to facilitate software testing, release and deployment at the operational environments of the Nancy demonstrators. In this video, we will be going through the basics of the Nancy CI/CD system that Netcompany-Intrasoft provides to the consortium partners. The Nancy CI/CD system is managed by Netcompany-Intrasoft and it has been set up on top of Linux virtual machines from Hetzner public cloud provider in Germany. You can see the virtual machines that compose the CI/CD system at the left of the screen. The main components of the CI/CD system are the Nancy GitHub organization, under which all Nancy component providers create and manage their code repositories and versioning. The Jenkins CI server, which manages the automated build, testing, and deployment workflows. A Docker engine for bundling the developed services and components into containers. The Harbor Container Registry for managing, storing, and distributing the produced binary, Docker images. The development and testing environment of Nancy consists of a central Kubernetes cluster which is used for automating deployment, scaling, and management of containerized applications. In the second phase of the project, the CI/CD system will also be connected to the different Kubernetes clusters of the Nancy demonstrators. In this context, the service and resource orchestrators will be integrated with the CI/CD system to manage the deployment service orders to the target Kubernetes clusters. The objective of this demo is to show you an example CI build, testing and deployment workflow towards the development and testing Nancy Kubernetes cluster. In this demo configuration, you can see in the left screen our local development setup where we have cloned locally the demo repository and we are about to push an update to the remote repository. On the bottom left part of the screen, you can see the Jenkins UI, from where we can monitor the status of the corresponding workflow. On the upper right part of the screen, we are monitoring the deployed resources in the Nancy development namespace of our Nancy Kubernetes cluster, which is dedicated to running functional and integration tests. Currently there are no deployed resources in this namespace. On the bottom right part of the screen, we are monitoring the deployed resources in the Nancy staging namespace of our Nancy Kubernetes cluster where the demo app will be deployed once the successful execution of the functional tests has been automatically verified. Similarly, there are currently no deployed resources in this namespace. Let's start by pushing an update to the remote repository from our local setup. After pushing, as you can see on the Jenkins UI, our Dockerized demo REST application is first built and the Docker image is created. After running some unit tests, the demo application is deployed at the Kubernetes cluster in the Nancy development namespace, as you will see in the upper right terminal. From there, some functional tests for the app are executed. Once the tests are completed successfully, the image is pushed to the Harbor container registry. The deployed resources get removed from the development namespace and they get deployed to the staging namespace of the cluster. Another workflow has also been created to release the resources from the staging namespace as well, once we do not need it anymore. After running this workflow manually from Jenkins UI, you can see that the demo app resources get released. This concludes our demo. Thank you for your attention.